Hi guys, this is Miss Rena here to talk to you, or I should say finish talking to you about wind. So in the last video, I wanted to go over what I call some kind of quote unquote causes for wind. So we did look at convection cells, we looked at, let's see, the Coriolis effect, and we looked at just plain old pressure gradients. Those can all be considered different, I guess, quote unquote causes for wind. Here's another influence and or a cause on the wind, and it just has to do with the texture of the surface of the earth. As the wind passes in between canyons and mountains, as the air passes in between, it's going to be caused to either speed up or slow down because of the influence of the topography of the earth. Here's a certain kind of trend: the flow of wind up closer to the stratosphere, so right up there about where the ozone layer is cooking, there's not a whole lot of mountains, buildings, things like that to run into, and so that upper level flow is relatively smooth and it's relatively fast. That's where you find jet streams. Those are the winds that govern which way the thunderstorms, the big storms, are going to go. So speaking of big storms, when we have large amounts of heat energy that are rising up over the ocean that tends to store and absorb a lot, we have that air that warms quickly, it rises up quickly. When it comes in contact with a mass of cold air that rushes in to take its place, and we factor in the Coriolis effect of the earth, the spinning, we'll end up with what we call cyclones. We call them hurricanes here, they call them typhoons in the Pacific. They have lots and lots and lots of water vapor content. We have lots of precipitation, very high winds, high rotation rates, again because of the Coriolis force of the earth, and we end up with some pretty nasty storms. An anticyclone is the opposite, and so now we're kind of talking about different types of winds, that upper level flow and cyclones. Anticyclone is really similar, except they're caused by a mass of cold air falling down. So we end up with a high pressure center instead of a low pressure center, and that mass of cold air is pushing air away instead of pulling air towards it, and we end up with opposite direction of spinning, so clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. Hadley cells are a type of circulation pattern. They're the ones pictured here from the last set of notes. So these are what they call the Hadley cells, and they're an effect of these winds coming up at the equatorial region and then falling down here. Again, this is going to produce, cold air that falls down here, right? And because this air is pushing against this air from the cold air that falls down at the poles, we end up with air rising even though it's not that relatively warm. Because that air rises, we end up with a lot of water vapor coming out of solution in the air. We get high rates of precipitation. That's Seattle, that's Oregon, that's the North American rainforest. So it's an interesting phenomenon. The convection cells are what happens when the energy that's kind of like saved up from the ocean currents and the air currents causes circulation patterns to happen. So again, convection means it's from heating due to the flow of fluids. The polar cells are the ones that happen up here at the North Pole and the South Pole. Here's another type of wind. So we'll call this one a sea breeze because it originates from the quote-unquote sea. And everybody that's ever been to the beach knows that the sand feels a whole heck of a lot hotter under the hot sun than the water does. And it's because its heat capacity is a whole lot lower. So it takes essentially much, much more energy to raise the temperature of this big mass of water than it does to raise the temperature of this sand. So this sand will feel hot. The air above it will feel hot, and it will rise quickly. This cool air will rush in to take the space of the void left behind by the warm air rising, and we get what's called a sea breeze. Once the sun goes down, the opposite happens, and you guys remember we talked about this in a warm-up. So the sun goes down, the temperature of the sand changes very quickly. Now all of a sudden it's cool because it doesn't hold on to energy very well. But boy, does the water hold on to energy that it's been building up all day. So now the relatively warm air is above the water. the cool breeze is going to come in from the land side, so there's the land breeze. Valley breeze is called that because the same volume of air that was going across the plains now has to squish between two mountains, and so the flux of air, that wind, the velocity of the air itself is going to increase. The wind feels higher, faster. Mountain breeze happens when the cool air falls down from the mountain top. It's more dense, and so it's falling down the mountainside, and it's going to cause, again, the air to move. Air masses happen when different temperatures and different humidities of air meet, and so we have a couple of prevailing winds. These are not so important to me that you memorize the names of, but it's good to understand where they come from. Continental winds are exactly what they sound like. They flow over the land. They tend to be not as high in water vapor content, whereas the maritime winds that have been flowing over the ocean, obviously, are going to be a lot more humid. Usually the continental air is cooler and drier. Usually the maritime air is warmer and more humid. When the two air masses meet, usually you end up with precipitation. So a warm front is exactly what it sounds like, advancing mass of warm air, and it's replacing the cooler air that it's next to. Cool front is when the advancing mass of air is cool instead, and so that cold air is the one moving the warm air out of the way. A stationary front is when you've got a mass of cold air, you've got a mass of warm air. The transitional zone between them isn't really moving one way or the other. An occluded front is when one air mass stops the movement or slows down the movement of another air mass. All right, so we're done talking about reasons for wind and different types of wind. Make sure you bear in mind all the different types of air masses and winds and all the reasons why they exist in the first place. So next time we'll talk about heat distribution. Until then, be ready for your quiz tomorrow. Good luck, guys.